You click on that. It's actually going through Dropbox and then Google Drive. I didn't. So if you click on that, then it should bring you to my Google Drive. And so what I did is in there, I put in some folders in there. If you click on that, and then you go over to the MyDAC, click on Curve Tracer, download that folder. So so these are all VIs that are going to be used for doing our curve tracer for our diode characteristics curves on the MyDAC. So, and then we're going to be using the other ones for when we get into transistors and FETs and all that. So, yep. So download those, and then we'll have those ready for tomorrow there.
So once you get to the link, where do you go? To Google Drive?
Yep, then go to the Google Drive, yep, click on that link, and then go to Google Drive, then click on MyDAC. Yep, and then just download that whole folder. Then you can put it under My Files in your MyDAC thing. Yep, just take a copy of it and download it into your folder there.
I got 4 folders that popped up.
Yep, there's going to be four different, there should be, you should have gotten 5. Should be, or maybe only, how many? 4? Yep. 4 plus a PDF.
So download all of them?
Yep, just download that whole folder. Yeah, and then we'll take a look at it tomorrow then.
Go this way here, all the way around up to there. It's going to bypass all this. No, you're not. See, well, you can have very little current going through there, I should say. Majority is going to be...
If you don't have access to Facebook, let me know and I'll put it on a flash drive.
So you're going to read 12 volts.
All right.
I think.
Let's take a look at...
like 11.
All right, what is number 2 there? What do we have for inputs there, Tyler? What's A?
2 is 0, so 0 volts, and B is over.
So A is 0?
Yeah.
Okay, so that's the same as my ground. And then B's open again?
Yes, sir.
All right. Yeah, this would be another good example. This one's very similar to what we just did. All right, so what's my first step that I want to do?
Circle active component.
Yeah, circle the active component. Put your polarities of your component in there, inside there. Okay, then what's my next step?
Treat it as an open.
So what's my next step that I want to do?
Treat it as an open.
Yeah, treat it as an open. And then what do I do?
Put your soft voltages.
Bring my soft voltages over. So so we know that these are all open, so we have this voltage divider again. So each one of these resistors are going to drop to 3 volts again, right? And we know that the current is going through them right now, just like that. All right, so what's my soft voltage going to be over on this side here, on my cathode side?
9.9 volts.
9 volts. Yep. So our plus 9 volts. Yep. So I'm just figuring out what I would measure for voltage from here to here. Plus 3, plus 3, plus 3 gives me my 9 volts. So that's going to give me my 9 volts on that side. And then what am I going to get on this side? On my anode side.
Plus or minus 0.
Yeah, plus or minus 0 volts. Okay? So is that diode a go or no go?
No go. No go.
No go. Okay? And it's going to drop the source voltage of it, and what's the voltage going to be across it then?
12 volts. Oh, no.
Not 12 volts.
No.
Take a look. All you have to do is it open and just figure out what the difference was on
9 volts.
9 volts. Yeah, just take whatever you did for your soft voltage. So it's going to drop 9 volts. Get that right, because that could change. Okay, so 9 volts current right now. Okay, so now we got that one analyzed. We know that one's not even part of the circuit anymore, so we don't have to worry about that one. Now we're going to go back and look at this diode, diode number 2, and what's my soft voltage on my anode side? 9 volts. That's the change. And then on this, on my cathode side, plus or minus 0. Okay, go or no go?
Go.
Go.
That was a go. That was a go, and that one's going to drop its 0.7 volts. Okay, now we have to go back. Now since this diode became a go, now we know things probably have changed. So now we have to go back and we have to reanalyze number 1. So once this one became 0.7 volts, once that one turned on, what we want to do is then we want to find out what is the voltage at this point then, at this given time. Oh, which way, yeah, I gotta keep on forgetting to do this. I forget to do it, remind me. Which way is my current flowing through this diode? From left to right or right to left?
Right to left.
Left to right.
Left to right. Okay, so we know my polarity's that way. So let's make sure we get our polarity. Okay, so now we want to find out what that voltage is at this point. So what's my voltage at this point right now?
0.7 volts.
Yep, a positive 0.7 volts. So it could be positive or negative, so make sure you watch your polarity. So it's going to be a positive 0.7 volts. And I'm bringing my red leads back to ground. So I know that this test point now just became positive 0.7 volts. Okay? So now we go back up and then we have to reanalyze this one and see what if this one made any changes to this one. So I'm going to go back up. Assuming this one is a go, what's my voltage going to be now on the cathode side?
Plus
7
volts.
Plus 0.7 volts. And then on this side it's going to be what?
Plus or minus 0.
Plus or minus 0. That stays the same. So did that diode change? Did that change to a go or no go?
No.
Still a no go. So we don't have to worry about it. Now we know that we don't have to go back and analyze anything else. And remember D3 is just hanging open. So we don't even have to worry about that one. We already know that's not even part of the circuit. So now we know that, just so we can kind of see it, we'll just say, well, we no longer need that one anymore. We already figured out what this voltage at this test point is, right?
Yep.
So we don't have to go any farther than that. We don't have to redo any work there. So now we know that from here to here, it must equal my 0.7 volts, right?
Yes.
So how much voltage, and since these are all equal resistors, and this isn't part of the circuit, how much voltage is dropping across each one of those resistors?
Yep.
What is it?
0.233 volts.
Millivolts.
233.3 millivolts.
Yep.
Yep. So each one of these are going to drop, get rid of that, 233.3 millivolts. Cross that one off, and that one's going to be 200. Okay? So how much voltage then is being dropped across R1?
11.3 volts.
11.3 volts. Okay, and okay, so we know that we have a positive 7 here, and my point of reference is here, so we know that the current is going from, we know that these polarities are correct, right? Those are all still, those polarities still stay the same. We know that the positive 0.7 volts is more negative than my positive 12 volts, so we know that those polarities are correct. We know that the voltage drop across it is 11.3 volts. We know that this test point is positive 0.7 volts. What's my VL going to be then?
4.66.6 millivolts.
You said 4 point or 466?
466.
Yeah, 466.6.
0.6 millivolts.
That's going to be positive. What number was that?
Number 2.
Yeah. So then we took a look. If we did the current paths on this one, move this over. So there's my circuit. So then we know that all my current is going to be, this is only source this time, so we know that all my current is coming out of my power supply, only one power supply I have. So all my current is coming out of my power supply, it's coming up. All my current is coming up through R4. All my current is going through R3. All my current is going through R2. And then it's going to come up to this current node here.
No, it's not.
But it's not?
Well, some of your current's going to go through there.
Yeah, you're right.
Not all of it.
Not all of it. No. No, all of my current is going up through there. That's the only source I have. That's the only source I have, right?
You got the ground on the other end, so it's going to go up through that parallel. Diode.
So if this is my only source, I know that all my current. Oh yeah, you're right. Yep. Forgot to draw this down. Yep. Forgot to draw this ground over to here. There was my first current node. Yep, good catch, Bob. So all my current is coming out of my 12 volts. That's true. Then I missed the first current node here. So here's my first current node. So some of my current is coming up through here, and then the remainder amount of my current is coming up through here. So then so I got some of my current coming up through here, some of my current coming up through here. Then I get into my next current node, and those two currents are going to combine. And then the only other place it's got to do is go through R1. So all my current is going through R1. And then back into my source there. Yep, I forgot to draw my ground down and tie that in. Yep, so some of my current's going up through here, some of my current's going up through here, those two currents combine, and all the current goes through in there, and up and around. And one way you can take a look at it too, while you're all looking at that, we know that since all these resistors are all the same value, we know that we didn't have much current going through these because of the voltage drops are so much smaller compared to because of R1. So we knew that we had very little current going through here. If I had the same amount of current going through here as I did R1, then all the voltages would have been the same. So the majority of my current then is going through where? Through R4, R3, and R2, or through my diode?
Yeah, that.
Majority of the time.
What's that?
So it's like that main branch is almost like being in parallel with the two that are up on top
Yep.
if you redrew it out.
Yep, so this one we can draw really easy.
Well, your voltage drop, yeah. 27 volts. That stays the same in parallel.
And then here.
Make sure you draw the ground all the way down. Otherwise you'll miss it.
And so they're just redrawn out there. So here's R1, R2, R3, R4. And then since now the diode is in parallel with R2, 3, and 4, they must equal to 0.7 volts.
Yep.
Yep. And so we know that we can see that all now. If we re-sketch it out, then we can obviously see that all my current is going through R4. So yeah, maybe before doing your current paths, not skip the step, straight line your circuit. Once you straight line it, then it does become a little bit more easy. If I probably would have straight lined it to begin with, I probably would have remembered to bring that ground down, because I forgot to bring that ground down and tied it in. So yeah, when you're doing your curve paths and stuff, it might not hurt just to re-straight line it so you can see where it's going. So is that what you calculated out, Tyler, before did you try it before we did it?
Yeah, I got that 0.7 kind of like you did, and I didn't like the way it looked.
So you just changed it up?
I just was like, let's do 2 and 4. I
Yeah.
want to see how.
Yep, I know, that was a good one, because that's an easy one to, I like to save like a couple of those easier ones so you can kind of get the hang of it, so you don't, if we do all the easy ones in class, then you're stuck with the hard ones at home to, yeah. Make it a little bit more sense though? Yeah, or deer in the headlight looks yet. Just stay off the shoulder there, yeah. Just kind of stay in the ditches and stuff until it all passes. Yeah. All right. Any other questions on those? I don't want to do any more of them because I'm save the fun for you guys.
So you want us to do all of them on?
Yep, do one on each individual. I printed out a whole pile of them over there. So, yep, just make sure you grab, what is there, 9 circuits? Yeah, just make sure you grab 9 of them.
Is it okay if you just straight line it and show the work that way?
Yep, whatever way, yeah, just so you show your work. Yep, just show me your polarities, of which way the things are. But why don't you guys, why don't we just, we'll bring your laptops tomorrow in and then we'll talk about the characteristic curves. So I had to kind of stretch this whole lecture out because Melissa's got to break it back.
Keep asking those
This whole lecture, I wasn't going to do any of this stuff. It was going to be a great day, but no, Melissa, thanks, Melissa. Stretch out the lecture here. And you know what? All right, so yeah, why don't you work on number 1 here for the next few minutes before you go into Matthew, and then that way if you have any questions, you can answer up on it. I don't have the answer. Oh, both, yeah. Yeah, but they're both open, yeah. We need box. You know.
Throw my laptop.
Okay.
No, I bought it. It's just pretty much caught off guard when he mentioned to bring him in. Shit. Yeah.